This is a tutorial on how to calculate a single dwelling using the Canadian Electrical Code, edition 2015. When we're out on the job site, we're walking through these homes and we have to have a method of calculating how many amps service we're going to put into them. So oftentimes we have to go through, count up all the loads, the square footage and so on to come up with the main service size. This tutorial is going to take us step by step through that procedure, and we'll start as follows. The first thing we're going to need to know is all the loads in the house and the footage, the meter square dimension of the house. We're going to go to section 8200 for our calculations. This is the ampacity and the needs of our house. We have a main floor of 150 meters squared and an upper floor of 80 meters squared with a full basement. Anytime we see the words full basement, that means that the main floor and the basement are the same size. So we'll revert back to 150 meters for that dimension when we get to our basement calculation. We have a baseboard heating demand of 15 kilowatts. 14 kilowatt electric range, and we have an AC air conditioning unit at 4,000 watts. We have a hot water tank, domestic hot water tank at 4,500 watts, and a clothes dryer at 5,000 watts. And we have a small dishwasher at 1,500 watts. These are our basic demands for our house, and as we go through, we will add them in piece by piece to our calculation. So our first rule is as follows. What we're going to do is we're going to read through all the rules that we have to pertain to, and then we'll take them one at a time and apply our information that we have for the house. The minimum ampacity, this is 8201, subrule 1. The minimum ampacity of the service or feeder conductor supplying a single dwelling shall be based on the greater of items A or B. Item A states that a basic load of 5,000 watts for the first 90 meters squared of living area, and it tells us to see Rule 8110, and we will look at that a little bit later as we come back through our calculation. And our second rule off subrule A is an additional 1,000 watts for each 90 meters squared or portion thereof in excess of 90 meters squared. And we'll look at that closer on our calculation and just sort out what all that means. At the first glance, it looks a little confusing, but it's really quite simple. We just need to figure out how many times 90 meters squared goes into our total calculation for our meters square for our house. And we'll come back to that and work through in a few minutes. The next on our agenda is subrule 3, and that's any electric space heating loads provided for with demand factors as permitted in section 62, plus any air conditioning loads with a demand factor of 100%, subject to rule 8106, subrule 4. And here again, we'll look at that rule a little bit later once we start doing our calculations. And we'll base that on that rule as well. Subrule 4 tells us that any electric range provided for as follows. 6,000 watts for the single range plus 40% of any amount by which that range exceeds 12 kilowatts. And like I say, we're going to come back through and apply these rules to our actual numbers that we have for our dwelling. Any electric tankless water heaters or electric water heaters for steamers, swimming pools, hot tubs, or spas with a demand factor of 100%. So this calculation is we have to go amp per amp, whatever these draw, it'll be at 100%. But in our house, you'll notice here that we don't have any of these loads, so we won't have to factor this in. However, we still have to go through the rule. Next rule tells us, subrule 6, of A tells us that any electric vehicle supplement or supply equipment loads with a demand factor of 100%. So these are charging units and so on. We have to take those at 100%. This is a fairly new rule because electric vehicles obviously are fairly new, and we have to start now allowing for those chargers in our homes. So any of those will be taken at 100%. Sub-rule 7 is any loads provided for in addition to those outlined in items 1 through 6 at 25% of the rating of each load with a rating in excess of 1,500 watts if an electric range has been provided for. So we're just going to stop there for a second, and we can see this is the part of this rule that's going to pertain to us because we do have an electric range. The second portion of sub-rule 7 is if you do not have an electric range. And we'll just read through it. It's not going to apply to our calculation here in this example, but we'll just go through it and see what it says. Or if you do not have an electric range, you have to go 100% of the rating of each load with a rating in excess of 1,500 watts up to a total of 6,000 watts plus 25% of the load in excess of 6,000 watts if an electric range has not been provided for. And we're not going to go through this, but in essence, what it's telling us is all those additional loads that are not included in those first 6 sub-rules. Any additional loads we're going to count, we would count those in, get a total of those, take the first 6,000 of that total, and then we would add 25% of the remainder of all those loads and add that in as a calculation. This does not apply for this, so we will not be looking at it in this tutorial. Our next rule states, this is the B portion. So the A portion is all our square foot or square meters plus any of the loads in the house or the dwelling itself. And sub-rule B tells us that we can do it another way, but we have to take the greater of either A or B. So we have to keep that in mind as we go. So sub-rule B tells us 100 amps. So the minimum service of a house is 100 amps where the floor area exclusive of the basement floor area is 80 meters squared or more. So if we have a house that is just 80 square meters or more and we have very little loads to calculate in it, the code is telling us that we have to at least put 100 amp service in it. And that's reasonable because if you have a house that is that big, 80 meters squared or more, someone else could come along and decide they do want a range, they do want a dryer and a hot water tank and so on. And so they say if it's 80 meters squared or more, we want to see 100 amps in that house. Second sub-rule under B is 60 amps where the floor area exclusive of the basement floor area is less than 80 meters squared. So that's obviously if the house is very small, you're not going to load it up with a bunch of things anyways. But minimum service for a dwelling would have to be a 60 amp service if it's less than 80 meters squared. So let's go back here and take this piece by piece, shall we? And apply the calculations. Our 8200 single dwelling tells us that the minimum ampacity of the service or feeder conductor supplying a single dwelling shall be based on the greater of item A or B. A tells us the calculation of items 1 through 6. And the other B is what we just looked at, is items 1 and 2. That's 100 amps if it's greater than 80 meters square, or 60 amps if it's less than 80 meters square. So let's do the calculation part to find out the very minimum, because we have to look at what is the greater between A and B. So let's find out if A is going to be greater than B. We go through our calculations, and our first one is the minimum ampacity of the service or feeder conductor supplying a single dwelling shall be based on the greater of A or B. So A is based on the total meters plus the load calculation. So the total dimension of the house, that's called our basic load. That takes into consideration the lights, the plugs, the fridge, and so on. Any of the loads that are 1,500 watts or less. Anything greater would be the additional loads, and as we have seen, and that's what we're going to go through here, this calculation. And of course, B is the very minimum that would be required. So let's have a look at A closely, shall we? A subrule 1 tells us a basic load of 5,000 watts for the first 90 meters squared of living area. And to find out our living area, we're going to have to see rule 8110, and then it tells us plus an additional 1,000 watts for each 90 meters squared or portion thereof in excess of 90 meters squared. So let's have a look at that one, shall we? The living area as pertaining to 8110, the living area designated in rules 8200 and 8202 shall determine the inside dimensions and include the sum of A, 100% of the area on the ground floor, that would be the main floor of the dwelling, and subrule B tells us 100% of any area used for living purposes on an upper floor. So if you had 2 upper floors, 3 upper floors, you would be taking 100% of each of those upper floors. And we drop down to subrule C, and it tells us that 75% of the basement area. So the basement area is a little bit less. The idea being you live primarily on the ground floor and the upper floors. And so they give you a little bit of break on the basement area. So let's look at the main floor area and the upper floor and the basement floor areas and do our calculation. So on the main floor, we have 150 meters squared, and we're going to take 100%, as our rule says, of that area. So we have 150 meters squared for the allowance on that floor. The upper floor, we have 80 meters squared. Therefore, we're going to take 100% of that, and that gives us 80 meters squared for that portion. And our basement area, we were told it was a full basement. So that means we're going to apply the main floor dimension, which is 150 meters, at 75%, which gives us a total on the basement of 112.5 meters squared. So we add up all those dimensions, main floor, upper floor, and basement, and we come up with a total area for our wattage calculation for this portion of 342.5 meters squared. So let's take that to the next step, shall we? Tells us a basic load of 5,000 watts for the first 90 meters squared of living area. And subrule 2 tells us an additional 1,000 watts for each portion, each 90 meters squared portion thereof in excess of 90 meters squared. So here's our calculation. We start out with 342.5 meters squared of floor area, and what we're going to do is divide 90 into that to give us how many portions of 90 meters squared that we have. So we divide 90 into the 342.5 square meters. That gives us 3 full portions of 90 meters squared, plus a little bit extra. Actually, it's almost 4, but we have at least 1 portion of 90 meters square. So that gives us a total of 4 portions of 90. So what we need to do is apply that to this rule. So we take our first portion of 5,000 watts and apply that to our first 90 meters square. So we're going to have 1 at 5,000 watts, 1 portion at 5,000 watts, plus 3 portions at 1,000 watts each. It gives us a total of 8,000 watts. So that's our first calculation that we're going to use. Now this is called the basic. It's kind of like if you buy a car. When you buy a basic unit on a car, you're lucky to get 4 wheels with it. So you buy all the extras. So this is kind of the same thing with the house calculation. This is called the basic load. So if you're asked what the basic load on a house is, it's just the minimal. It's the square meter area. It includes plugs, lights, and the small appliances that are 1,500 watts or less. It's called the basic area. You don't want to forget that because that can be a little bit confusing if you're asked for the basic load. Remember, it's not the total load on the house. It's just the basics. It's your lights, plugs, etc. So now we have a number of 8,000. We're going to start our calculation now. So I always like to stress here, as you're doing these calculations, try and be as neat as possible, create a structure so that you don't forget anything. You can quickly review it to see if your calculation is correct. If you don't do this neat and tidy, sometimes it's easier to overlook the obvious, and that's how you make a miscalculation. It's not too bad in school. If you make a miscalculation, you lose a few marks on your test. But once you start doing this out on the job site, houses burn down, we can come into some serious problems on this. So you want to make sure that you can do these calculations and do them nice and neat and get in the habit. It's good to develop that habit right away, and you'll find yourself making less mistakes later. So that was our first calculation, our 8,000 watts, and we're going to come back to that format as we start adding our loads to the house. Our second load that we're going to talk about here is our electric space heating and our air conditioning. So let's look at sub-rule 3, shall we? Any electric space heating loads provided with the demand factors as permitted in section 62. So we're going to look at that rule here in a second, but let's just run through this rule. It says, plus any air conditioning loads with a demand factor of 100%, subject to Rule 8.106, sub-rule 4, and we'll look at that as we go. But first of all, we're going to look at the electric heating and figure out what that calculation is and we're going to put that back into our calculation page. So let's look at section 62. We have to go to section 62 when we deal with the heating, and that's 62.118. That's demand factors for service and feeder conductors for our heating loads. Now it tells us in sub-rule 3, drop down to sub-rule 3, and you find out, notwithstanding in sub-rule 1, where a heating installation in a building for residential occupancy is provided with automatic thermostatic control devices in each room or heated area. The ampacity of the service or conductors or feeders supplying heating devices only shall be based on the following. Now let's just explain that rule just for a second. Anytime we have electric baseboard heating, they have thermostatically controlled devices in each room that's heated. So that would mean there's a heater in the bedroom, it would have its own thermostat. In all the bedrooms, they would have their own thermostats. Any of the living areas will have their own thermostat for that specific area. When you have this kind of a situation, the code gives you a little bit of break on it because they kind of feel that you're not going to have all the heat on at the same time in the house because each heated area has its own thermostatic control. So they're going to fluctuate. They're going to come on, off, all over the house. So they're going to give you a little bit of break on the total wattage as far as your heating is concerned. So what it tells us here is the first 10 kilowatts of total heat that we have in the electric heat on baseboard heating, the first 10 kilowatts of connected heating load at 100% demand factor. So that means of your total heat, we're going to take 10,000 watts out of it and we're going to calculate that at 100%. We'll see how that works into our calculation in a second. Let's look at the B factor here, and we have the balance of the connected heating load at 75% demand factor. So anything above 10,000 watts, we're going to take at 75%. And that's that little break they give you because we have individual thermostatically controlled devices for each heating unit in the rooms. So let's break down that calculation, shall we? So the first 10 kilowatts of connected heating load at 100% demand factor plus the balance of the connected heating load at 75. So here's our calculation. First 10,000 of 15,000 watts at 100%. So we start with a number of 10,000 watts for our calculation, and then we're going to add in the balance of 5,000 watts at 75%, which that calculation gives us 3,750. And so we have a total baseboard heat demand on our main service calculation of 13,750. So now we're going to go back to our calculation page and start adding these to the numbers that have gone before. So we're going to add this to our floor area. So our baseboard heat for our home demand factor on our main service will be 13,750. So let's go to our next load, shall we? And it says plus any air conditioning loads with a demand factor of 100% subject to Rule 8.106 sub-rule 4. So now let's go to that rule and have a look at it. It says where it is known that electric space heating and air conditioning loads are installed and will not be used simultaneously, whichever is the greater load shall be used in calculating the demand. So we know one could be on at one time or another. So if they're not used at the same time, we're going to take the greatest load. That's just reasonable, because if one's on, we're going to take the greater of the load, because that's what the service is going to have to handle. And that's how we're going to, what the calculation that we're going to use. So in this case, what we're going to do is take 100% of the 4,000 watts, and that's going to give us a 4,000 watt addition to our load. Now, why did we choose that? The reason is, in this case, we would have to find out, in this case, in most cases, in fact, when you have electric baseboard heating, you do not have an electrical central furnace, which would eliminate one or the other. In this case, you may have some what they call window shakers or air conditioners they put into the windows, and those could actually run at the same time as your baseboard heat. Now, you can have those wired in with contactors, etc., and have those so they don't come on and off, but typically on baseboard heat you don't do that. That's quite an expense. But I have actually done that, is wired the baseboard heating in conjunction with the AC, and one or the other will come on. And where this is logical is you could actually have, if they're not connected together, you could have both loads on at the same time. And that's quite reasonable. Your air conditioning could be wanting to cool a room if it's hanging in the window, could be wanting to cool the room, and the baseboard heat, if it's not connected together, interlocked is what it's called. If it's not interlocked, you could have both of them fighting each other, and the thermostat, electrical thermostat for the heating says it's cold in here, and it's on full blast. The air conditioning unit says it's hot in here, I want to put some cool air in here. And of course, you could have both of them at the same time. So if they are not interlocked, you have to take, at that point, 100% of the air conditioning, just in case they're on at the same time. So let's add this number into our calculation page. So our AC will be 4,000 watts. And you can see how you structure this, and I've laid this out in a way that, you can pattern this layout of mine and just keep adding these things up as we go along in a neat and fashionable way, so it's easy to determine what your loads are and easy to see if you've made a mistake or overlooked something. So now we go on to our next rule, sub-rule 4, and we talk about electric ranges. Any electric range provided for as follows: 6,000 watts for a single range plus 40% of any amount by which the rating of the range exceeds 12,000. So what that means to us, let's just sum that up. What that means is whatever our range is, in this case it's a 14,000 watt range, we're going to take the first 12 kilowatts of that range and apply 6,000 watts to our load. So what is that? How does that affect our calculation? We take the first 12 and we apply 6,000 to it. So our first number in our calculation is 6,000 for our range, 6,000 watts. Then we're going to take 40% of the balance of 2,000, because that's how much it exceeds 12 kilowatts. And 40% of 2,000 watts is 800 watts. Add those together and we have 6,800 watts for a total demand for our range on our main service. Back to our calculation page, we add that range into our previous calculations. So you can see how we're just building one load upon another to find out our total ampacity. So we go to sub-rule 5 now, and it talks about any electric tankless water heaters or electric water heaters for steamers, swimming pools, hot tubs, spas with a demand factor of 100%. Now we don't have any of those loads in here, so we can just overlook this one for now. So let's move on. Next one is sub-rule 6, any electric vehicle supply equipment loads with a demand factor of 100%. And here again in this dwelling we do not have this load, so we can bypass that one. We get to subrule 7, any loads provided for in addition to those outlined in items 1 through 6 at 25% of the rating of each load with a rating in excess of 1500 watts if an electric range has been provided for. So that's that two-part rule, whether or not you have an electric range. And of course the first part is what we have because we have an electric range. The second part of this rule pertains if you do not have an electric range. And that part of the rule actually gives a little provision that if one day somebody came in and wanted an electric range, it gives you a little bit of a buffer. That's how that calculation works. I know a number of people that would never cook with a gas range, and they like to change it out and put an electric range. They just feel safer. So the code recognizes these kinds of things and builds a little bit into the calculation if there is no electric range. So let's go back to our calculation and see how this pans out. So we have some additional loads that we're going to look at that are not included in subrule 1 through 6. And these loads are as follows. We have a hot water tank, and whenever we have a hot water tank, it does not classify as a tankless hot water tank because obviously a hot water tank is called a hot water tank because it is a hot water tank. It has a tank incorporated in it, a storage for hot water. So it fluctuates on and off on a pretty regular basis. So we can take just a portion of that, and the portion in this rule tells us that we have to take the 4,500, which is the total element load, and multiply that by 25%. That gives us a total wattage demand on our main service of 1,125 for that one. Our dryer is 5,000 watts. We're going to take 25% of that because we didn't have a dryer laid out in subrule 1 through 6. So we're going to add that in here, and we can take that at 25%. That gives us 1,250 watts for that load. And dishwasher, we're told we have a dishwasher at 1,500 watts. Well, the rule at the beginning told us that anything that is greater than 1,500 watts are those additional loads because we're right on 1,500 watts. Obviously, we're not greater than 1,500 watts, so we don't have to allow anything, but I like to put it in here just showing that we have cited that rule, and so we have 0 watts for our dishwasher. So we have a total for our additional loads. That total comes to 2,375 watts. So let's add that figure now into our total calculation. As we're going down here, we have a total calculation once we're adding in those additional loads of 34,925 watts. Total demand on our calculation. So now we want to take that and turn that into amps. So let's see how we're going to do that. If we go back to 8100, right at the beginning of this section of our demand section, it tells us how to calculate according to our voltages. So let's just read that rule to refresh our minds here. When calculating currents that will result from loads expressed in watts or volt amperes to be supplied by low voltage AC systems, the voltage divisors to be used shall be 120, 208, 240, 277, 347, 416, 480, and 600 as applicable. Now our service here is a 2-wire 240 volt systems, or 3-wire, sorry, 240 volt system. So we have a neutral and 2 hots. In that system, it's going to be called a 120 240, and we saw that on the first slide. That was the service that we're going to have. So because we have 2 hot lines with 240 volts between, we will use that for our calculation. So what does that look like? Let's have a look here. So we have 8100 is our current calculation. Our total demand was 34,925 watts. We're going to use 240 for our divisor. We'll divide that into our watt value. And we get a total of 145.52 amps. So that is the size of service we would have. We would base our size on that calculated load. Now, when we look at the subrule B section of this calculation, we remember that that was the very minimum you had, and we had to take the greater of A or B. The 145.52 is the number we're going to have to choose because that's greater than the B portion of 8200. This has been your tutorial on your service and feeder calculation for a dwelling unit.